Hello everyone. My name is Muhammad Azfar Jamal, and I'm a student at Electrical and Electronics Engineering here at Bilkent. I'm in Physics 101 Section 2, and for my lab experiment, we will be calculating the value of spring constant K by using the conservation of mechanical energy.
This experiment is based on the conservation of mechanical energy, where the kinetic energy of the moving puck, given by half mv square, is converted into the elastic potential energy of the spring. This is given by half kx squared. In a system with no energy losses such by friction or by air resistance, all of the kinetic energy is converted into the elastic potential energy of the spring. So we can equate them and calculate the value of the spring constant. Thus, this experiment demonstrates the conservation of energy laws and also shows that the spring constant remains independent of mass.
Here is my experiment setup. I have an air table to minimize friction, a spring attached securely to a wooden block using double-sided tape, and a puck with weights attached. There is also a spark timer to measure the initial velocity of the puck as it moves towards the spring, and a ruler to measure the distance between the sparks to help us calculate the velocity and maximum compression of the spring. In the experiment, we will slide our puck towards the spring, and using a spark timer and a ruler, we will measure the time and distance the puck takes to travel to the spring. This allows us to calculate its velocity. Similarly, we can also calculate the maximum compression of spring using spark timer. Now let's talk about the results. I conducted 4 trials, each with a different mass. For each trial, I calculated the puck's velocity and the spring's compression. Using these values and the formula relating the spring constant to mass, velocity, and compression, I calculated the value of spring constant for each trial. As you can see, the calculated values of K varied across trials, and the graph of mass versus spring constant did not give us a slope of 0. This was unexpected because theoretically, spring constant should be independent of mass. Therefore, the y-intercept also didn't provide us with the true value of the spring constant.
This happened because there were several potential sources of errors in the experiment. The air table may not have been leveled and also did not fully eliminate the friction in the experiment, which led to energy losses affecting the conversion of kinetic energy into the elastic potential energy. The spring and weight also did not perfectly align during the collision, which led to irregular motion and incomplete compression of the spring. Moreover, determining the maximum compression of the spring was challenging as the sparks did not perfectly align with the moment the spring was at maximum compression.